All right, let's move on the next topic on statistics. And today we are going to discuss one of the second part of the topic. If you remember in the first episode, I was talking about the overall statistics can be divided into broadly two categories. The first one is the basics, which is all about understanding central tendency and central measures. And the part B of that is understanding measures of variability, which is what we'll be talking in this video on what is variability and how to measure that. And there are different synonyms or jargons that are used. Like I said, statistics is all about using jargons to confuse people. So the different synonyms that are used for variability are dispersion, variability, distribution, spread, and so on and so forth. But for the most of it, variability and dispersion will be the one that will be frequently used in terms of talking about this terminology. So in the first part A of central measures, we were talking about what is the notion of central tendency and how to measure that. In terms of how to measure that, we in detail covered mean, median, and mode. Like that, in this topic, we'll be talking about what is the concept of measure of variability, and then in the future videos or episodes, we'll be talking about what are the different ways where we can measure this in different algorithms. That's what it is. Okay, so without getting any further delayed, let's jump into that. What I've done is I've taken the same example and we're going to talk about the part B, measuring or measures of variability. First, understand what is variability or what is distribution or what is spread, the different jargons. Let's first try to understand the concept before we measure that. So what I've done is I've carried forward the same example that I've used in the central tendency portion, one of the examples. So over here you see what we see is a class of 313 students, 313 students, and their marks for one subject, maths. That's on the left side, okay, over here. On the right side, what we see is for the same class, what are the marks for the students for mechanics. And we are going to use the group frequency model here. And by that, what we mean is instead of repeating the line items, we are going to combine the groups of the students. 3 students out of the 313, for example, 3 of 313 students scored 100. That's what it means. 25 out of the 313 scored 85, and so on and so forth. So whole of this is maths and the whole of this is mechanics. Interestingly enough, these are the two subjects where most of the diploma students kind of struggle or fail. So I've just taken those two examples. And like as always in the previous episodes, what I've done is I've added some visuals plotting this two things. I have a visual to plot this one with these values, and I have a visual to plot this one for these values. For this one is for the maths, and on the right side we have for mechanics. Okay, and what we have done is we have also calculated one of the central tendency measures. So I've taken mean for an example, the arithmetic mean, okay, for the whole class, which we already discussed in the episode where we are talking about mean, how to calculate that. So what it means is I've also drawn the line, the whole arithmetic mean for this class. If you do the calculation, we add all the values and divide by the number of students, 313. That value that we get is 57.268. And I've also drawn the mean line. This is the value. This is 57.268, and this orange line kind of indicates that mean line or the mean value. And what in essence it means, like we have seen, or what it implies, let me not use the word mean and mean, English mean and arithmetic mean interchangeably. So what this arithmetic mean of 57.268 implies is basically, it implies that in a way we can also think about that each of this 313 student, every single student in this class of 313 on an average scored 57.26 marks. That's what it means. So we don't have to go through the different distribution of the marks, but we can assume that every single student has scored 57.268 in mathematics. Likewise, on the right side, what we have seen is for mechanics, and for the distribution for mechanics, if you see here, the mean is 57.0351. For the same class, what we are trying to say is every single student on an average, if you calculate the average score, on an average, the arithmetic mean, we can say that every single student on an average has scored 57.03 marks in mechanics. That's what it means. Okay. And the question that I ask to myself and to others is on this topic is, okay, based on this two distribution, one for maths over here and one for mechanics over here, how would I know which one is more consistent? Where are the students, which subject the students have more of a consistent marks, or in other words, for which subject the marks are all over the place, distributed in a different way, in a different pattern with respect to the mean line. Okay, for example, if you see over here, there are few values which are distributed here in the region of the mean line. There is one value which is slightly away from the mean line, and there are a bunch of values over here which are further away from the mean line. So that this particular visual shows that the values or the marks for the student are kind of distributed unevenly or scattered or more varied or more dispersed with respect to the mean line. And over here, if you see the values over here, if you take any value, the overall values or the overall marks for the student in mechanics is pretty much distributed evenly around the mean line. They are not distanced very far. The average distance or the pattern in how they are distributed with respect to the mean line are pretty much consistent. It's not like over here, one is over here, few are here and few are here. It's pretty much within some striking distance of the mean line. Okay, that's what it means. So that kind of tells us that the distribution or the type of pattern that we get in terms of how the marks are scattered with respect to a central tendency measure. In this case, we took the mean. That's what it means. Okay, and that answers this question. So what we're asking here is, which subject shows more variation for the marks, or which subject is more consistent on the marks for the whole class? Okay, how are the numbers or the values scattered, and what's the pattern look like? These are different questions meaning the same. I've just used different words to give a flavor and better understanding. So what basically it means is, for mechanics, it's more consistent or it does not vary much. The degree of the variability is not that much. Whereas for maths, it is all over the place. It's scattered more relatively than the mechanics. Okay, that's what it means. So that's what tells. So the pattern tells us what is the degree of the variability, and that's what is a concept of variability or distribution or dispersion or spread. All are different jargons, like I said, but the meaning is very simple, and we'll be frequently using, from an exam standpoint of view, these two terms, variability and dispersion. Okay, but even if you get in exam distribution or spread, you can understand they're talking about the same essence. So basically what it means, the way a given set of numbers are distributed or spread or scattered, it tells us the how part. It tells us how the values are distributed with respect to the central measure. It could be any central measure. In the above examples, we took mean, but it could be any measure defining the central tendency. It could be mode or it could be median. But what happens is, typically in the part A, if you see, when we spoke about the central tendency and the central measures, it talks about what is the exact value, what is the mean, what is the exact value for the central tendency, or to measure the central tendency, whether it's a mean or a mode or a median. So the part A defines the what part, and the part B, in terms of measuring the variability, it talks about how the values are distributed with respect to the central tendency. So the first part is what, and the second part is how. That's kind of the difference on how we calculate that. And what we have done is, in the first part, we understood the concept of central tendency, and we knew that there are many ways to calculate this measure, and we looked at these three measures, mean, mode and median. Similarly, in this video, what we'll do is we have understood now what is a concept of a variability or dispersion or distribution, all of these jargons. And in the subsequent videos, we will talk about how to measure this. What are the different ways to measure this, like we did with the central tendency. In this episode, I'll still introduce you what are the different ways to measure that, and in the subsequent videos, we'll talk about how exactly we need to measure that. Okay, so let's keep going. Okay, so what are the different types of measures or measures of dispersion? How do we measure dispersion, or distribution or variability? Okay, there are two ways to measure this. One is the absolute way and one is the relative way, and we'll look into this at a high level in this video, but we'll talk about the details in the next episodes. So there are three ways to, out of the many, there are three popular ways to measure the absolute measures of dispersion. I'll come in a minute what is the absolute part of that. So one is called as a range, then we have got mean deviation, and then we have got variance and standard deviation. These are the three popular things. There are many other measures also on how to measure absolute. And the difference between absolute and relative is very simple. If you say there are two students, say student A and student B, okay, both are students, okay. So let's say this student has scored 70 marks out of say 100, and this student has scored say 75 mark out of 100, okay. So in absolute terms, if you see, the denominator is the same. So in absolute terms, we know that student B has scored more than student A in absolute terms, because 75 is greater than 70, right? This part is greater than this part, okay. So we know that student B has better marks or a better score in one subject as compared to A. So that's the absolute measure. We just have the same denominator, and then it's a like to like comparison. We compare with, it's called as apple to apple comparison, okay. We are not mixing the fruits, we're just comparing the same comparison. Whereas if I give another instance where I say student A has still got 70 out of 100 in a subject, whereas B has got 100 out of 200, okay. The base is different. Out of 200 marks, student B has got 100. Out of 100 marks, student A has got 70. And ask the same question. In this case, who has got a better score, right? So in this case, we cannot have an absolute measure comparison because the denominator is different. So we'll have to have some way of relativity so that we can do an apple to apple comparison. And the typical way we do is we do express this in terms of a ratio and then calculate the percentage. What do we do? Okay, student A has got 70 marks out of 100. So here we have defined the ratio, okay. And to convert this into a percentage, we multiply by 100. And similarly, we say, okay, student B has got 100 marks out of 200. Again, there is a ratio here, okay. And to convert this into a percentage, we multiply by 100. So whatever answer we get, we are going to get in terms of percentage, okay, over here and here. And then we'll compare the percentages so that we can meaningfully compare which student has got better marks. In the first case where we're talking about just absolute numbers for the same denominator, both the exams are for 100 marks, we kind of realize that student B has a better mark than student A. But let's see what happens here. So when we compare this into percentage over here, student A has 70% because 70 on 100, this gets cancelled and this becomes 70. And over here, if we calculate, this becomes 50 because 100 of 50 exactly got 50%, okay. So we got 50%. So now we realize that when we take the ratio, because the bases are different in terms of relativity, we say that in this case, okay, student A has got better percentage than B because 70 is bigger than 50. But percentage is a relative measure or a ratio of two numbers, and that's it, then we are able to figure that out. So same fundamental applies here for variability, okay. When you're trying to measure something in an absolute terms, for certain examples, absolute measures might be applicable better. So in that case, the measures, the popular measures are range, mean deviation, variance, and standard deviation. Whereas when I'm trying to measure relative measures, because we are not comparing like apples to apple or like comparison, so we need to bring in the ratio aspect like we did here. In those cases, we call something as relative measures of dispersion, also called as coefficients, okay. Another jargon, and I think I should put this in red because this is where the most of the exam questions will be around about the coefficient. When we talk about coefficient, it's nothing but it's a relative measure relative to something, relation between one number to another number, or a ratio of two numbers. You can remember this part because over here we have calculated the ratio of two numbers, right? So we know that in that case. So whenever we talk about relative measures or the coefficient, we're talking about ratio of two numbers. So, and the beauty is each one of this absolute measure, each one of this range, mean deviation, and variance and standard deviation, each one of this will have a corresponding relative measure, because the ratio or the relative measure or the coefficient is calculated still on the absolute measure. For example, even if you see here, in this case also, we still need in the ratio the absolute part. So 70 is the absolute number, we still need that. The numerator part is still, we need that. So the ratio is still calculated using the absolute measure. Similarly, over here, the relative measures or the coefficient are going to be calculated based on these three things. And each of the relative measure will have a similar kind of a name with respect to the absolute measure. For example, the relative measure for this absolute measure range will be called as coefficient of range. If you see here, coefficient of range. So for each of the absolute measure, we will prefix with these two words, coefficient of something and coefficient of something. We have an absolute measure called as mean deviation. So we'll have a corresponding relative measure which will be calculated based on mean deviation, and that relative measure will call them as coefficient of mean deviation. And likewise, we'll be calling coefficient of variation for the absolute measure, variance and standard deviation. Okay, that's kind of the broader things about how this functions, and we'll talk about each of these measures and how to calculate both absolute and relative in the next few videos. And as a quick summary wrap up, what I've done is I put some visuals. So what we are trying to understand now, like how we have calculated the central tendency, variability or dispersion or distribution will tell us how the numbers or the values are scattered with respect to a central tendency measure such as mean. And there are two broader ways to calculate that. One is the absolute way and one is the relative way. Like I also put the tree here. Okay, two ways to calculate that. Absolute just compares the numbers, so that we need to have the same base or same criteria or a level playing field, where we say it's an apple to apple comparison. Like I gave the example of if the score is out of 100, then we can compare two students. And in that, we have got three popular measures to do the absolute measures of dispersion or variability. Again, the jargons here. And then we have, for each one of these, we have a relative corresponding coefficient or relative measure, which is prefixed by the word coefficient of range, coefficient of mean deviation, and coefficient of variance or relative standard deviation. Okay, and in terms of relativity, we're talking about a ratio of two numbers because the denominator could be separate, and we would need to understand whether which is a better number. To get a sense, then we use kind of a relative measure, which is nothing but a ratio measure, which is nothing also called in statistics as a coefficient, like I give the percentage example. So that's how the measures of variability is done, and in the next episodes we'll be seeing in detail some of this, and then that will help you understand what is important and how should we think about that. And I'll also put some separate videos, not from an exam standpoint of view. When I get a time, I'll put some extra shots to give you some interesting insights. Why can't we use how can we use one in certain aspects and not the other one, and why it kind of disturbs or gives a different picture. So why is it like that? So in what scenarios we should use which measure, whether absolute or relative, and how should we think about that? Just like I did in the mean, mode, and median. When should we use mean? When should we use mode? And when should we use median? All measure central tendency in a different way, but there are nuances on when we should use that. Again, like I said, you don't have to go into the detail or even scratch the surface from an examination standpoint of view. But if you're interested and curious to know how it affects, I'll put a separate video for the curious learners, not for the learners who are strictly confining themselves on the syllabus. So that's a wrap up on the intro to variability or dispersion or distribution and how to measure that. And I'll see you more in the next future episodes on how to calculate this.